Hi, so in this video, we'll discuss LeetCode problem 3255. Find the power of k size Subarrays 2. Okay, both 1 and 2 are actually same. Actually, only the difference is the constant. Okay, so the statement is that you are given an array of integers nums of length n and a positive integer k. The power of an array is defined as its maximum element. If all of its elements are consecutive and sorted in ascending order, and -1 otherwise. Means like suppose k is equal to 4, so subarray of size 4, it will be actually uh, power of an array if like the length is actually k. Okay, and the power actually number are actually sorted ascending order, consecutive and sorted. Consecutive means the difference like 2 3 4 5, this is also possible. 10 11 12 13 also possible. This is consecutive and also in the sorted order. Okay, and else it is -1 otherwise if it is not falling in this criteria. Okay, means this is not consecutive, any one of these not consecutive, like 1 2, then 2 3, these are also sorted. Okay, and also for 2 3 4 5, these also sorted, right? But this is actually not consecutive. 2 and 4 are not consecutive, right? So that's why this is not the power of an array. Okay, so we have to, you need to find the power of all subarrays of nums of size k. Okay, so I have to find the power of all subarrays of size k. So here actually k is equal to 4, that way I have searched for 4 length array, or actually I will check this is actually consecutive or not and also sorted or not. Okay, else it will be -1, right? So the answer array length will be n minus k plus 1, because n is the total length, and if the subarray if the subarray length is k, so like for this actually k is equal to 3. So first of all, this will be one subarray, like this is also second subarray. This is 3 4 3 again, 4 3 2 again, then 3 2 5, 3 2 5, right? So this is how many actually subarray possible of length 3? 1 2 3 4 5, 5. So how many actually total actually 5 subarray actually possible of k is equal to 3 length, right? And what is total length of the nums? 1 2 3 4 4 7, 7. So what are you doing? We are actually take the 3 length subarray, so -3 plus 1. So this is what happened, 4 plus 1, this is, that's why 5. Okay, 5 subarray is possible, okay, of length k. So I have to, that's why answer also length is 5. Okay, now I have to check that is subarray of length k is power or not. Okay, so how will you check? Like for this example 1, okay, example 1 is 1 2 3 4 3 2 5, right? And k is equal to 3, right? So first 3 length subarray is 1 2 3. So this is actually sorted. Yes, this is sorted, and also consecutive, 1 2 3 consecutive. So this is actually one possible k length the power possible power of an array, right? So what is the power? They have to mention that the power is the power of an array is defined as the maximum element. So what is the maximum element of it? 3. That's why I will push this actually 3. Got it? Then next possible subarray is 2 3 4. This is also sorted and also consecutive, so the power will be 4. That's why this is actually 4. Got it? Next possible subarray is 3 4 3. So what is actually the sorted? This is not sorted. Okay, if it's not sorted, then I have to check this is consecutive or not. Okay, so this is actually -1. Okay, that's why this is -1. Okay, then possible subarray is 4 3 2. This is not sorted, so this will be -1. Then possible subarray is 3 2 5. So this is also not sorted, so that's why -1. That's why answer is 3 4 -1 -1 -1. 3 4 -1 -1 -1. Got it? In this way. So what is the brute force approach actually? Like the first one, there is a 2 problem, right? 1 1 and 2 and 2. So if I write the brute force approach on the first problem 1, that time it will actually pass actually. Okay, so that's why first discuss the brute force approach. Okay, then actually we will optimize this. So brute force approach is this: first of all, generate all possible subarray of length k. So I know this is actually starting about subarray, okay, which is starting from 1. Okay, then I will check what like I know this from this one, I actually need k is equal to 3 length subarray. So I will generate this. Okay, I will take this 1 2 3. Okay, so I will actually iterate k is equal to 3 from this I is equal to 0. Okay, so I will actually take these 3 element, I will check, and then I will check this is sorted or not, and also consecutive or not. If it is consecutive and sorted both, that time I will do the last value, like I plus k minus 1. How? Like I is equal to 0 and k is equal to 3. So 0 plus 3, it actually 3. So 0 1 2 3. So 3 actually not actually correct position, so I have to adjust this by 1. Okay, so 2 index I will at the end of the this current subarray starting from 1. Got it? So 1 2 3, I know this is a starting point. I know the what is the starting point. Starting point is 0, I is equal to 0, and I know what is the length of the subarray 3. So what will be the end? End point will be j is equal to 0 plus 3 minus 1. So 2 index. Index 2 will be the end index of the current subarray, which is starting from I is equal to 0. So you can actually one other thing that what is the last value? This will be the always maximum. Why? Because first of all they are saying that this will be sorted in ascending order. Ascending means should be in increasing, and also they are saying that this will be consecutive, like 1 2 3 4 x plus 1 x plus 2 x plus 3 in this way, right? So it is sure that the whatever the last value I have, if it is sorted, that then and consecutive both are actually true, that time if I know this is actually good subarray, that time whatever the value in the last position, this will be our answer, right? This will actually contain the maximum value of the this subarray, right? Understood the logic, right? So whenever I found that, okay, I'll check. So for each position, whenever the starting a new subarray or starting I, so I will generate a k length subarray, then I will check that this is actually sorted or not, and also consecutive or not. So in this way, how many actually starting position are possible? Like I is equal to 0 possible, 1 possible, 2 possible. In this actually possible n minus k. N is equal to 5, here is equal to 3 4 5 7 length, and k is 3. So this is actually 4. You can just take 0 1 2 3 4. If I this is actually last element, actually I can actually take. How? Because if I start from 2, actually have I k is 3 elements on the right side? No, there are only 2 elements on the right side of these 2. So I can't complete actually 3 length subarray. That's why last index, the possible last index will be this 4, n minus k. So what is which is the starting one index can be for each subarray I is equal to 0 to n minus k, right? And for what are doing for each position, for each starting position, I will generate k length subarray, and then I will check that this subarray is sorted or not, and consecutive or not. How can I actually check the consecutive or not? I will check that the difference is 1 or not, right? So this should be actually difference should be like x and y. So y minus x should be 1. If it is not 1, anything else like 0 or minus 1, anything, that time it is not actually sorted, right? Like perfect subarray. So that time what will do? So what is the time of this for this approach? Like for each position, how many actually starting position are available? Suppose n minus k, 0 to n minus k. So roughly this is actually n. And for each position, I will actually generating k length subarray. So n into k. So this actually roughly n square time complexity. Got it? Like there actually starting position of subarray is in n position are possible to start a new subarray, and for each subarray starting position I will actually create the k length subarray. So that's why time complexity for n position I actually calling n k times. K times actually means to generate the k length subarray. That's the time complexity will be n into k. So it roughly actually n square. Got it? So how can you actually optimize this? You can actually optimize this. How? So example is 1 2 3 4. 1 2 3 4. Then 3 2 5. 3 2 5. Okay. So I know this actually. I can't take decision that this is actually sorted or not. So this actually I will take this. Okay, this is actually sorted, and I also count that how many actually sorted I have seen till now, till this index. Okay, then I will come to this 2. Okay, then I will check. Okay, 2 and the previous index value is sorted or not. How will you check? 2 should be greater than 1. All right. and the difference of 2 minus 1 should be 1. So I'll check, okay, this is actually sorted, means this is actually perfect. So I can actually take this into the previous subarray. If it is present, then what will be available? How many actually length of the subarray should be good subarray? This will be actually 2 is sorted. So this will be previously I have actually 1 into the current that previous subarray, and also I'm adding this 2. So 2 subarray length will be 2 of good subarray, right? Now we come to 3. Okay, 3 is actually sorted. 3 minus 2, 3 greater than 2, and the difference of 3 minus 2 should be 1. Okay, this should be 1. Okay, I'll check. Okay, this is actually true. This is also true, and this is also true. So I can actually take this into the previous subarray. So how many actually count? Count will be 3. The subarray length will be 3. 1, 2, 3 actually sorted. You can actually check sorted and good consecutive also. Now I try to take 4 into the previous subarray. I will actually check the condition. 4 should be greater than 3. Okay, and the difference of 4 minus 3 should be 1. Yeah, both are actually true. So I can add this into the previous subarray. So that's why length of the previous this subarray is 4. That's why the here actually 4 also stored. Okay, now this is actually 3. Okay, then 3 is greater than 4. No, then I do not have to check that this is consecutive or not. I do not have to check. Okay, this is false, means what? I can't take 3 into the previous subarray. So I have to take this alone, this element. So I will start 1, because only one subarray of new subarray is taken. This is starting from 3. Okay, then I'll come to 2 actually. Then I'll check, okay, 2 is greater than 3. No. So again this will be 1, because this will not be possible. So I have taken a new subarray of only 2 is present. Okay, then I will come to 5 actually. Okay, then 5 will check, okay, 5 is greater than 2. Yes, and also the difference of 5 minus 2 is equal to 1. No. So then I can't take 5 into the previous subarray. So again I will start a new subarray of 5. Okay, you can actually check, like whenever we are trying to take 3 into this, like 1, 2, 3, this is sorted. Okay, then 2, 3, 4, this is also good subarray, and also this actually consecutive also, right? Now whenever trying to take 3, 4, 3, you can just check this is not sorted, right? So I will check, okay, whenever trying to this actually our ending position 3, that time if I try to take in the previous, like what is the count? Count is 1. The subarray length is 1, because I can't add into the previous, I can take this 3 into the previous subarray. So that's why the count is 1. Okay, so I will take the decision, okay, this is not actually good subarray if I add this 3, 4, 3, which is ending at 3. Okay, like you can check in 3, what is the count value? 3. So this actually k is equal to 3, and also the length of the subarray also 3. So this is actually good subarray. So I will add this value into our answer. So answer will be 3 currently. Now I will come to this index 4. Okay, this counts also 4. Okay, 4, and the current length should be 3. K is equal to 3, but it already 4, so it's okay to 4 greater than 3. So I will add this 4 into our answer. Then I'll come to this index. Okay, then I'll check, okay, what is the length of the subarray? Good subarray. This is actually 1, which is actually less than 3. Less than 3 means k. So I will not be able to take this. So I will add -1 here. Got it? In this actually you can actually check the what are the count actually I have. Actually I will check the which is the maximum length of the subarray which is ending at this I. This is actually good means sorted and consecutive. Got it? So if it is not actually sorted and or consecutive, that time I will try to take a new subarray of length 1. Got it? So just put actually code. So I have to take n is greater of n length. N is the length of the array, input array, and initially 0 index will be always 1, because I don't have to check anything previously. I can add or take or not this current index. So that's why initially this is 1 length subarray ending at 0. Okay, so I is equal to 1 to I less than n. I will actually iterating. What is iterating? I'll check the current number and the previous number, the difference is 1 or not. Okay, then I will add this into the previous subarray. right? So that time if it is difference is 1, okay, that time what will each greater count will be at index I, the length of the subarray will be 1 plus the previous index length of the subarray end at I minus 1 index. Got it? 1 plus, why 1 plus? Because the current ith element will be added into the previous subarray, because this is also a sorted and consecutive. That's why I can actually take this into the previous subarray. Got it? And else what will happen? I'll start a new subarray, because I can't take this current element into the previous subarray. Got it? That time I will start a new subarray of length 1. Got it? Now I have actually calculated all the actually length of the subarray, maximum subarray, which ending at index I, and also sorted and consecutive. Okay, that I will store in the current index I. Now I will take an answer that I have to return, and I am iterating from I is equal to k minus 1. Why? Because the subarray length will be k length of the subarray. So this starting at the ending index will be k minus 1 initially. Suppose k is equal to 3. So 0, 1, 2, 3. So this will be actually the first subarray of length 3. These 3. So what is the index of this? K minus 1. So that's why I'm starting from these two, because these two are this is not actually, you can actually check, you can start from iterate from here actually also, but this doesn't mean anything. Why? Because this is actually sure that the length of the value of the count length of the subarray of here 0 and 1 index will be always less than k, because I have not seen any at least k elements, then how it is possible, right? So that's why I am starting from I is equal to k minus 1. This is possible, like k length subarray is possible or not, I will check. And when it will be possible, if I see at least k elements, that time I will be able to take the decision. If I have seen less than k element, then I am sure that this will be not able to generate k length subarray. So that's why I'm starting from I is equal to k, I less than n minus n, and I plus plus. I'll check is greater value of I is greater than equals to k. Why? 1, 2, 3, 4. Suppose 2, 3, 4, 5. So the count will be what? 1, 2, 3, 4. This will be the count. So this also generated 3, 4, 5 also will be generated new good subarray, right? But here actually what will you store? 4, which actually greater than equals to 3, right? 3, 4, 5. So if it is already crossing k, so it is good for us, right? So the length is already good. Like if I 1, 2, 3, like 2, 3, 4 also 5 also actually sorted 4 length, right? So that's why if it is greater than equals to k means it is actually sure that this is actually good subarray. So that time whatever the value in the nums I have, that will be our answer, the power of the metric, power of the array. Because actually I is equal to what? I is equal to k minus 1. Here actually 0, 1, 2, 3, 0, 1, 2, 3. So here actually 2 will be 4, first 4. So this actually sorted. I have actually already shared the observation that the value of the last index will be the actually power of the matrix, power of the array, because this is sorted and consecutive. So the matrix maximum value will be present in the last index. That's why whatever the value that I have in the current index nums I, this will be actually answer. Else what will happen? This is actually not a good subarray, which actually have a not sorted and consecutive. So that time I will do push minus 1, like for this 1 to 1. So 1 to 1, then 1 to again. So this will store 1, 2, this will again store 1, this will again store 2. So here actually what will, like k is equal to 3. So this actually first ending index of the subarray of length 3. So I will check, okay, 1 is less than 3. So this is actually not possible. So that time I will insert minus 1. Okay, and at the end return answer. Got it? So what is the time of this? Like here actually we are generating all possible the length of the subarray ending at I. What is the maximum length? Even also consecutive and sorted. So that actually take time big of n, because we are iterating each number only once. And here also we are starting k minus 1 to n. So this also we can actually assume that this actually we are iterating n times. So total time will be big of n plus n, and so this will be big of n, right? You actually got it, right? How actually optimize this from n into k to n into n. Got it, right? And also understood the logic also, right? Thank you.